Hey everybody, in today's video we're going to add to our little level here, we're going to add this one-way platform that we can jump up through. We're going to add the ability for our player to crouch, and we're going to add the ability for us to be able to jump down through a one-way platform when we're crouching. James Nice submitted a homework assignment again. He's such a great part of this community. I love James. I couldn't help but just laugh at this awesome sprite that he's got. But let's see what he did here. I'm not going to show his code. He did a pretty good job. Let's see. Jump, crouch, can jump down through. Looks really excellent. Now, I think the only thing James did different than me was that his crouch does not allow him to jump when he's crouching, I don't believe, based on looking at his code, which is something I'm going to do in this video, but you know, that's okay. If you want to be able to have the ability to jump from a crouch when you're not on a one-way platform, that's what we're going to build. But thank you, James, for submitting this, and thank you for creating that amazing sprite. All right, so let's talk about what we're going to do as we implement the crouch feature in our game. Now, one thing is we would probably want a visual to represent that our player is crouching. But because we don't have a sprite to animate, we're not actually going to implement that part of the crouch feature today. But one thing that we will do is we will address this collision shape, because right now, if we were to crouch, then you would assume that the collision shape would maybe be half the height or something like that, right? So we'll go ahead and we'll hook up code to do that. And we will also obviously have a state. We'll be able to see it reflected because of the label. So even though we don't have the animation in this episode, you will still know that you're crouched based on the state label. And I'll also show you how we can use this debug visible collision shapes so that we can actually see that collision box changing. The other thing that we're really going to be building into this is one-way platforms and being able to jump down through those platforms. Okay, so we're going to actually cover quite a bit of ground, not just a simple crouch state. But let's go ahead and start with just building the crouch state, because that in and of itself is pretty straightforward. One of the first things we can do is just create or add a new node. So I'm just going to do Control A and add a node. And of course, rename it to the name of the state, which is crouch. Okay. And then we want to find one of these scripts we have. I'm going to pick idle and I'm going to duplicate that and call it crouch. And let's get that sucker open before we assign it, because I want to make sure we change this class name so that it's unique. Player state underscore crouch. And then we can actually leave this jump in here maybe, and I'm gonna go ahead and just comment out the run. Let's save this, and then let's put our crouch state right here on crouch. Okay, so we've got a new state. We need to make this a access as unique name kind of node like the others, because one thing that we have to remember to do as we add new states to our player is come to our root player state class and include that reference. Okay, so then that way we are able to just simply return that crouch state. One thing I want to just touch on real quick, and I'm going to do a deeper review of this at the end of chapter 1, so just in a couple episodes here. But some of you who are newer are kind of wondering, how is this working? How is, returning a state working, yada, yada, yada. And we'll be doing an in-depth step through that code for those who are new and want to review that. But I do want to just kind of review how this works real quickly. So because we have this class player state and we're including these onReady variable references within this, each of these states that extends the player state will have access to those variables, because that's within the scope of it, right? Because essentially when we say that this player state crouch extends player state, that means it has all of these properties and these functions, plus anything else that we add to the crouch script, okay? And so even though we don't have those defined here, we have access to those variables, and it's pulling them from our player state. Now, if we were to have a player state in a node that didn't have these states with these names set to access by unique name, then this player state script would start throwing errors, because this is going to be looking for nodes in the scene tree of this type with this name. Okay, so hopefully that makes a little bit of sense, and if it doesn't, then stick with it. It'll begin to make more and more sense as you learn to work in Godot and as you learn about GD script. But now that we've got our crouch state just kind of set up, let's just come in here and actually we don't need to do anything yet with crouch. Let's just hook it up from our idle. So here in the idle state, let's go ahead and make it so that we can enter the crouch state and then we'll know that it's working. So where I'm going to handle this actually is in my process. See, in the process function is where I'm currently doing my player direction comparisons. And so I want to keep that consistent. So here we're checking if our X direction is does not equal 0, right? Which would be greater than or less than 0. And then we return the run state. We can do another check on the direction to see if we need to crouch. And that would be, you probably guessed, on the Y direction. There's other ways we could detect this. We could just listen for down being pressed, but how I've coded it, I think this is how I would prefer to do it. So I'm going to add an elif, okay, so that if that first condition doesn't pass, then it'll check this one. And we're going to say if our player.direction.y, right? Because that's the axis that we want to check. Now in this case, we could say something like greater than 0, right? Because greater than 0 would mean we have a vector pointing down. Just a reminder to those who are new, negative on the y-axis is up and positive is down. And so we could just check to see if we have a positive value. Now that's going to be sufficient for most inputs. But as you recall, going back to that discussion we had on, I think it was episode 3, but when I talked about the input drift and thumbsticks are unique because, you know, if you've got like your D-pad or you're using the keyboard and you're using the arrow keys, the only values that you're going to have on your direction are essentially 0 and 1. But the thumbstick introduces a range from 0 to 1, right? So it could be 0.1, 0.2, 0.99996, you know, some random value. And we do have some unique code that we added to make sure that our drift and that dead zone is used per axis. But what I'm going to do here on this player direction, I don't want it to be really sensitive because I'm, you know, if I've got my controller here and I'm running to the side and I just barely press down, I don't want to duck in that situation, right? I want the player to have to be pushing down on the D-pad or on the thumbstick a certain amount before I try it and crouch. So what I'm going to do is I'm just going to say if the player direction.y is greater than or equal to 0.5. So they're going to have to basically pull that thumbstick down half of the distance down before it's going to register or pass this condition. Okay, so if that happens, then what we'll do here is we'll just return idle, or not idle, crouch. Crouch. That's the Russian version of crouch, if you're wondering, but we're going to go ahead and just run this. So we should enter the crouch state by pressing down. Wow, it's taking forever. Okay, here we go. Now, real quick, before I even test this, you'll notice all this weird stuff on here. That's because while we were in here, I went to debug and said visible collision shapes. So if you don't have that on, you can turn that on. And if it's kind of obvious, right? We're just seeing all the collision shapes that are here in our scene. You can see the box for our player. Now, when I press down, he enters the crouch state. Of course, we have no conditions to leave the crouch state, so we're stuck in it. But we know it's working. Okay, so let's go ahead now and let's add a condition to be able to leave the crouch state. So let's open our crouch.gd script. And we'll do basically the same thing. Let's just come to our idle. So here we've got this. I'm going to uncomment this. We're not going to return a run function. I mean, this makes sense, right? Like if we're pushing left or right, then maybe we do want to return run. One thing with this state machine is there are times when we don't have to route every state transition because what we can do here is just handle getting to the idle state. And because the idle state already has this check in there, it's only going to take one frame of the game for idle to switch to run. And so I'm not even going to worry about this. If for some reason you feel like you need to, you could always change that. You don't have to agree with my decision here, but I think this is pretty sufficient, and it also just limits the amount of code that we need to write to make this work. So what we will check here is our Y direction. So we'll do the opposite, right? For idle, we were checking to see if our direction Y was greater than 0.5, and then we would return the crouch state. So instead, we could just say if our Y direction is less than or equal to 0.5, then we know that the thumbstick is higher, right? In this case, we'll just return idle. So I'm going to go ahead and save that. We'll run one more time. And I'm going to go ahead and use my PlayStation controller right now. So you can see I can move. And now if I hold down, I crouch. And when I let go, I go back to idle. And if I crouch and then I'm pressing to the left or right while I'm also pressing down. You can't maybe see what I'm doing, right? I'm just rolling around on the keys here. He's going to stay crouched. I just unplugged my controller a little bit. And I think that's actually a desirable outcome, because generally in games, we don't want run to override crouch if they're holding down the down button, at least in my opinion. So you can change this if you want to, but I want the state to be kind of sticky. So once you crouch, you really have to let go of the down before he'll stop crouching, okay? Now, we don't have a way to go from run to crouch, so I had to push down enough that I stopped pushing left or right. So let's go ahead and account for that next. Okay, so I'm going to open my run, let's see, my run state script here, which it looks like I already opened. And we're just going to add a condition in here to be able to enter the crouch state. And you can see we've got our player direction code, just like we have been doing with the other states. But in here, we do want to account for either going to idle or to crouch from run. So let me just go ahead and look at the idle state. And this little elif that we wrote right here looks good to me. So I'm going to copy those 2 lines of code, go back to, there's the run, and just add these. So we've got a crouch transition set up from our run state, and I'm going to go ahead and just test this. And this should feel a little bit more responsive, so you can go to run to crouch without needing as much play on the controller. And that's going to add to that sticky feeling of crouch. Now, one thing I want to do next is let's just refine our crouch a little bit. Let's deal with making the collision shape adjust, and we can even scale the sprite for fun if we want to, even though we're not going to keep that. And then we'll also just do a little bit of refinement on the crouch. I think when you're running and you crouch, I think it's abrupt if it just stops instantly. And so I'm going to add a little bit of a deceleration, and it's optional. You can follow along to learn how we do it. And if you don't like it, then don't keep it. But otherwise, it's just there. And actually, let's start with that first. Let's go over to our crouch state, and I'm going to add an export variable that we're going to use to determine the deceleration rate that we have, or how quickly we'll slow down. And so we'll just call this variable deceleration rate. And I don't know how to spell that. That's a hard word. This will be a float. By default, maybe I'll set it equal to 10. Okay, so a couple things that we can do in here. We don't need to do anything right now on enter, although we will come back to that. But let's go to our physics process, because this is where we handle the velocity, right? And that's what we want to adjust. So instead of simply setting our player velocity x to 0, what we're going to do in this case is we're going to subtract. So I'm going to say minus equals, and then we're going to put what we want to subtract from our current velocity. And what we'll do is we'll say player.velocity.x times deceleration rate. And then we also need to multiply this by the delta. Okay, because this deceleration rate is a rate over time, and that's what we're going to use this delta for, to know just how much. So by default, 10 would be like 10 pixels per second, right? But we're going to say that this is happening more than once per second. So how many fractions of a second have passed? That's how much we'll decelerate. So we'll just adjust our player velocity. Even though this is always going to run, this is going to get close enough to 0 that you're not going to notice any movement pretty quickly. So let's go ahead and just run the game and try this. So if you're running and you enter crouch, then you can see it kind of slides to a stop. Boom. Okay. And now if you want, you can adjust that number. If we wanted him to decelerate very quickly, then we could come to our crouch state and we could set this to like 100. That's going to feel instant. Yeah, see, there you go. At that point, we just don't even do it. Just set the velocity to 0. But let's say we wanted to do something like 2. Ooh, he slides. Okay, so if you have an ice world, then maybe you could set this deceleration different, or add like a modifier. You know how we had the gravity modifier in the jump and fall videos? You could add a similar thing here that's like a friction modifier. And so if they're on ice, it gets lower. But I'm going to reset that to 10 because that's the value that I liked. It's kind of cheating when I build it in, but I do think it's good practice. Once you settle on a value that you think is kind of ideal, go ahead and set this. And where these export variables would come into play is if you have another team member who's working with you, or maybe if you're making players that have variation, right? So you're using this player script and these states, but you've got 2 different versions of a player, then you might have slightly different values on each of their abilities, right? So maybe one of them slides more, etc. So let's now handle the physical response to crouching. And by physical response, I mean this collision shape. And, you know, I said we weren't going to really animate this sprite, but let's go ahead and just make it shrink for fun. So how we're going to do that is we're going to, for the sprite, we can access that directly. We could change the size or we could change the scale. Now for the collision shape, that would be an obvious approach as well. But actually what I would prefer to do in this case is to create two different collision shapes. Because I don't want to have to change this and worry too much about it. Now, this is maybe splitting hairs, but this is just how I want to do it. So we're going to have our collision shape 2D. I'm going to duplicate that, and we're going to have a second one. And you can see this has collision shape 2D2. So let's go ahead and give these more appropriate names. I'm going to call this one collision stand, and then the second one we'll call collision crouch. Just like that. And then what we can do, now you got to be careful. If I try and resize this, you see something funky happening. You see how they're both resizing? This is a common problem you'll run into, and I would say this is a built-in feature of Godot that confuses people. Because I duplicated this node, it duplicated the shape here as well, which means that we're referring to the same instance of shape data. So what we need to do is select our collision crouch because we want to have a different shape, and you could either clear this and create a new one, or you could just come up here and come down to make unique. And what that did is it made this a unique instance of this rectangle data. Okay, so now you can see I can resize this and the other rectangle on our stand has stayed the same. Okay, so what we'll do with the collision crouch is we'll make it roughly half. And then of course, this can be adjusted later. I'm actually gonna make it somewhere around 30 pixels tall for me because I know this is gonna be close to where I want it when we add a sprite. So you may wanna follow along, especially if you're gonna use my sprite sheet, but otherwise, you know, make it fit what you want. Okay, so now we've got two different shapes, and we don't need both of these active at once. And so what we're going to do is we're going to select the collision crouch shape and just come to this disabled option. It's right under the collision shape 2D underneath the shape. Just disable it, boink. And you can see that it turned this box kind of gray, and our stand one is still blue. If we were to disable the blue one, then it would be gray as well. And we'll be able to see that color change with this debug setting where we are making our collision shapes visible. So we'll just go ahead and run that real quick. You'll see that there's going to be two boxes on our player. You can see here's the crouch shape and there's the stand shape. But we're only activating one at a time so that we don't, you know, have double physics trying to happen on the collisions or something weird like that. But now in order to be able to access these, what I'm going to do is I'm going to go into my player script. And then in the player script, we want to drag in and get a reference to both of these collision shapes. And right now, what I'm going to do is I'm going to make a new region up here. You don't have to make it a region if you don't want to, but I think it's just nice. And this is going to be a region for onReady variables. And then we'll just end that region. Okay, so these are going to be our references. And I'm just going to hold, and I actually want the sprite as well, because we talked about we could change the shape of the sprite. So let's go ahead and do that. So I'm going to just hold shift and click all three of those. You can also hold control and click one at a time, or you can just drag and drop each of them individually. But I'm going to do this, and while holding control, drop them in there. And we're going to have these onReady variables that are going to reference our nodes. Okay, so now we can manipulate them through code by using this name in our code. And I do want to change this sprite. I don't necessarily want to call it sprite 2D because I know it's a sprite 2D. I'm just going to call it sprite. And then I think collision underscore stand and underscore crouch are good. Okay, now that we have this set up, if I go into my crouch state, I can now access those nodes and we can make changes to them. And so in our enter here, obviously we're going to play an animation when we have it. But right now what we can do is we can enable or disable those collision shapes accordingly, right? And so what we want is we want to disable the standing collision shape and enable the crouching one. Okay, so what we're going to do is we're going to say player dot, and then the first one is collision stand. I know alphabetically crouch came up, but let's go ahead and just do this one. And then we can say dot disabled equals true. Okay, so that's going to disable the stand state. I'm going to go ahead and just copy and paste this. And then we will take our crouch collision shape and turn the disabled to false. If we were to run this right now, this will work, except it won't when we exit. So just take note here, we've got our two rectangles, right? There's the standing one and the crouching one. The crouching one is gray, standing is blue. But when we crouch now, you can see that the crouching one is blue and the standing one is gray. So this means that all of our physics collision that's happening on this player to this player node that's a character body 2D, it's looking at its collision shape. And because we only have one active at a time, it's just going to use the active one. I'm using terms mixed here. Active, meaning it's not disabled, right? But as I was pointing out, we left, we're in the idle state, and we still have the crouch one enabled. So what we need to do is just use our exit function to handle that. So here in our crouch exit, I'm just going to copy both of these lines of code, paste them in the exit, and just swap the values, right? So now we will not disable the stand, and we will disable the crouch. And then just by doing that and saving it, we don't even have to run the game again. I'll just go back, and it should work. Yeah, there we go. So now you can see that they're toggling. Okay, and it doesn't matter what we do, how we transition out of that state, it's going to work. Okay, so that's how I'm going to handle my collision shapes on this one, and we'll do the sprite here in just a second as well, but everything's looking pretty good. Okay, I'm in my player scene. I just want to revisit this. We've got this sprite 2D, and this sprite is interesting. If we were to scale this by like 0.5, it's going to scale from its center right there. And long run, we're not going to be scaling this. So this is almost a non-important step. But what we want to do to make it look like it's crouching is we could scale it. And then because of the way it's working, we'd have to move it down as well. Okay. So I'm just going to kind of find, we could use the animation player for this, by the way, but I don't want to. It's going to be again, a use that we're going to have to get rid of. So I think it's easier to just do it in code and then just comment out or remove that code later. So it looks like values that I would want is a position of -15 on the Y and a scale of 0.625 on the Y. So I'm going to come into my script, and in crouch, I'm going to go here and I'm going to say player.sprite.scale.y. Is that going to work? Equals 0.625. Now let's go ahead and just test that and see if it gets small when we crouch. It definitely is. Hold on. Oh, because I had it scaled to begin with. Let's go ahead and clear that, reset that, and we're get my sprite here again and just drag it up to where it needs to be. Okay. So now if I save that and run it, okay, that's kind of working. It got small. Go back to our script here. We'll take this and we can paste this and just set it back to 1. And then we also need to handle the offset, right? To get that sprite to, when it's crouched, to make it look good. So I'm going to go back to that 0.625. That's 6.2. So by default, our Y position is -24, and then we want it to become -15. Okay, so here we'll say player.sprite.position.y equals -15. Is that right? Copy that. I zoomed in on my code. -24. So when he stands up or leaves crouch, it should go back to that position. So let's just test this real quick. Okay, that's working. So now we've got animation happening on that crouch state. So now it looks a little bit better. And then if we want, we can come in here, go back to our debug. Don't need to see the collision shapes maybe, although we might turn it back on during this episode. I'm starting in that crouch state because I've got it all wonky and saved that way right here, right? So let's reset the scale, set that back to -24, and there we go. Okay, done with the crouch animation. Now I just want to point something out here. So hopefully it's kind of obvious, but anytime we change a value here in the enter of a state, chances are we're going to want to reset that value when we exit. Okay, so that's kind of what we're doing here, right? If we're changing our collision settings specific to how this state functions, then when we leave, we need to set it back to whatever the default is. Now, if you find yourself making some of these changes consistently across multiple states, then you might want to make a function within the player script to do that. And then the states that need to can just call the function, right? To like set collision to this or whatever. Okay, but for now, this is the only state we're going to have that's going to do anything with crouch. And we will, by the end of this chapter, remove this scale and position change. Okay, so it's fine to keep this right here in the crouch state. Okay, so something fun. I want to point out that with how we wrote our code, if you were following along with me, we do have the ability to jump from the crouch state, just like that, right? And so that's good. We don't need to really make any change there. But we will be making some changes because now we're going to get into this one-way platform concept and how that needs to interact with our crouch state. And so just looking, well, let's look at our script here. So our crouch script, we can see that hopefully in your handle input, you've got this: if event is action press jump, then return jump. Okay, that's why we can jump. And that's all well and good. But we're going to be hijacking this and doing something different depending on the type of platform we're on. This is where this crouch state goes from super simple to a little bit more complicated. Okay, but in order to flesh this out, we need to come over to our playground. And we need to make it so that we have a one-way platform to test on, because a one-way platform allows the player to jump up through it and then they can still land on top of it. And I think when we have that kind of platform in a game, it's nice that if you're crouching, you could jump down and drop down from it, okay? And I hope most of you agree that that's a good, worthwhile feature to have. So let's build a platform that does that. And I'm going to go ahead here in my playground scene. I'm going to Control A and add a sprite 2D. And kind of like we've done, we'll make a texture. You can see here's my sprite. It's empty right now. Let's make a gradient 2D texture on this. And instead of doing black or like what we've done before, let's come in here and I'm going to give this a unique appearance. So I'm going to go ahead and change this. I like this HSV wheel. In fact, you can change this in your default settings, and I tend to do that in most of my projects. But I'm going to pick a blue-like color on this first stop, and then I'm going to come to the second stop, and we'll pick another blue-like color, but drop the alpha all the way to 0. Okay, so we're going to get this fade from solid to transparent. And then I'm just going to change this real quick. I'm going to make my fill go from 0, 0 to 0, 1. So it's going to go top to bottom. And there we go. Okay, this is going to represent my one-way platform. And I'm going to come in here and scale this. Now, this isn't the best way to make a platform, obviously, but this will be a pretty good way to do it for now, right? Until we have our sprite sheet set up, which will be in chapter 2. So I'm going to have this one-way platform like this, and maybe that's too big, but doesn't need to be very big. Something like that. Okay. Just put it right here. Now, of course, it's just a sprite right now. We're just going to fall right through it. And it's on top of the player because of z-index stacking. We'll deal with that stuff later. If you wanted it to be below the player, you could just move it in the scene tree like that. And the draw order is basically related to the scene tree, unless we manipulate other values on the nodes, okay? So we've got this, where were we at? I'm going to give this a name. That way it's easy for me to find it. Okay, so what do we need on this one-way platform? We had added a static body on all of these, and we can do that here as well. Okay, so we'll add a static body. And, of course, our static body needs a collision shape. Okay, what collision shape do we want? Just a simple box, rectangle. Okay, now, real quick, this is kind of awkward. We can just resize this to match. But I want to point something out. We've been scaling this sprite. So if we look at it down here, under our transform, we've got a scale, and it's kind of wonky. Okay, but we can see there's a width of 64 pixels and a height of 64 pixels. So let's just come to our collision shape and type this in here. And you'll see that it matches. That's because of the way the inheritance works. So the static body and the collision shape are being scaled according to the scale set on its parent, okay? So that's really all we need to do is just make this match. Then you don't have to come in here and try and size it perfectly. Now what we need to do, this is now a collision shape, right? So now our player can land on it, but it's not one way, right? So if we jump beneath it, we're going to hit our head on it. So what we can do is you see with the collision shape 2D selected, there's a one-way collision option. And really that's all we need to do. You'll notice that it gave it this downward pointing arrow. Okay, so this arrow is indicating the direction of the one-way collision. It has a margin setting. We're not going to really worry about that. But now what will happen is if we run our project, we'll still land on this object. But if we come beneath it and jump, we can jump up through it. Okay, and I happened to set this just the right height that I can jump up and land on top of it. That was almost by accident, but I did intend for that eventually. So that's nice. So there we go. So now we've got this nice one-way platform. You can see I don't land on it until I get high enough, and voila. But now when we're crouching, I want to be able to jump down through it. The default behavior that we've built is that you just jump when you're crouching and you press jump, okay? So let's go ahead and set up what we need to make that happen. We're going to need to do some detection, right? We're going to need to know, are we on a one-way platform or are we on a regular platform? And so we'll use some new configuration settings that we haven't yet used in this project with layer masks to accomplish that. We'll add a raycast that'll help us detect what type of platform we're on, and then we'll add some extra code to our crouch state so that we can drop down. Okay, so let's start by talking about the collision. So I'm just going to select one of these here. You know, I mean, you could select any. Looks like I've moved that a tiny bit. Okay, so this static body on this block and all of these blocks, they're not one way. And you can see in our collision settings, they have a layer and a mask setting. What the layer does is it just identifies what layer this collision object resides on, okay? You could think of it as a group or a label, and this is on layer 1. What a mask does is it doesn't determine what layer the collision resides on, but it does determine the layers that it is detecting. So technically, we don't need a layer mask on our ground because we're only using this to detect like for our players if they're on it. So let's go ahead and just take this concept full circle. If we look at our player, he's got collision settings as well. You can see he's on layer 1 and he's looking at layer 1. Okay, and likewise, our one-way platform is on layer 1. So let's do this. I'm going to show you an example here. We're going to leave a collision layer on our player, and we're going to turn the mask for layer 1 off. So what this means is our player is on layer 1, but he's not looking at any layers. And let's run the project and see what happens. He didn't collide with anything, right? Because that mask layer was turned off, he's not looking for collision on any layers currently. So let's turn this back on and let's turn layer 1 off. Again, I'm looking at my player here. Okay, so I'm adjusting his collision settings. I'm gonna go ahead and run this. Even though he's not on a collision layer, right? He is still looking for collision on layer 1. I hope that's making some sense. Essentially what we've got is the physics and the collision shapes in Godot are separated into 2 domains, and it is just what I've been describing, right? Where do I reside? And what am I looking for collisions with? Which layers do I care about when I'm looking for collision? And so I'm going to go ahead and reset these layer settings on our player. They are important, however. And what I'm going to do is I'm going to actually open our player scene, select the root node, and we just want to make these the default settings. And so I'm going to expand collision. Nope, wrong collision. There's 2 collisions. There's a collision underneath the character body 2D, right? That does safe, it's not what we want. There's collision under the collision object 2D. We don't need our player to be on a layer right now, so I'm just going to turn that off. But we do want him to collide with layer 1, and I want him to collide with layer 2. We're going to use 2 different layers here, okay? And one thing we can do, as you can see, we can edit the layer names. I'm going to make this a little bit easier. When you click on that edit layer names option, it brings up your project settings, so you could find this just by going through there. And now you can see our layer names for our 2D physics is what I'm on, right? We've got render names, we've got physics names, we've got navigation. So layer 1, I'm going to call ground. And then layer 2, I'm going to call one-way platform. Okay, so we've got 2 types of layers that the player can interact with right now. It's the ground and the one-way platform. I'm going to go ahead and close that. That doesn't change this view here, but now if you hover over it, you'll get a tooltip. You can see how it now says one-way platform, and this one says ground. And then what's nice is if you aren't sure which is which, not only can you hover it, but you can click on this little menu here, and now that we've added layer names, any named layer will appear as an option in this list. So I can select it from this as well. That way you don't have to remember numbers. Okay, so we've configured our player. He's now not on a collision layer, but his collision is detecting collisions on the ground and on the one-way platform layer. So if we come back here, let's go ahead and grab this one-way platform. All of our other collisions here were already assigned to layer 1, which is the ground layer. So I'm going to select the static body on this guy here. And first, let's turn it off. Okay, and let's just run that. So by turning off both settings, now that doesn't do anything, right? It's just as if it were just a texture and nothing else. But we want to assign this not to layer 1, but to layer 2, to the one-way platform layer. And we should be able to run again. And now we're able to interact with it, even though it's not on layer 1, right? Okay, so now you can see how those collisions are making sense. You're probably wondering why we would separate them, and it's strictly so that we can differentiate which type of ground he's on, right? If he's on ground or on one-way platform. But we had to set this up first to begin with. So there's your first introduction to collision layers if you're new to Godot. For those of you who've been following along with me for a while, this is probably common sense kind of stuff. Now, in order for our player to know what type of layer they're on, we're going to employ a raycast kind of trick. So we're coming here to our player scene, and we're going to add a new type of node. So the node that we want is called a raycast 2D. And I guess I could go back into that description, but what a raycast does is it just like shoots a line and it checks for collision along that line. Okay, so you can see the line right here. And what's fun is you can come and like click this little red control dot and just drag it around. So if you want it to point here or there or whatever, okay, you can change that. Alternatively, we can come in here to our target position. That's going to control this arrow, the direction and the distance that it goes. And so really, we only need to check just a few pixels below the player. So I'm going to just go with 0, 4. So it's just going to point down and check down about 4 pixels. Okay. Now, what's fun is we can check for collision. You see how we've got a collision mask setting? Now, this doesn't have a collision layer option because the raycast doesn't provide collision information to the physics engine, right? As far as like objects go, but it can detect collision with those collision shapes. And so it only has a mask setting. There's also some other important settings here, like is it enabled? Excluding parent is a good one to turn on normally, because that means if by chance we had a collision shape in the player that was assigned to layer 1, when we have this exclude parent on, it's not going to detect collision with itself. Okay, it'll only detect collision with other nodes in the world. But really what we want is we want this collision mask set to the one-way platform, because that's what we want to check for, right? Hit from the inside, we don't really need this, but I don't know that it makes too much of a difference. You can turn it on and off. If you're having bugginess where it doesn't seem to be detecting some collisions, you might need that setting. But I don't expect we'll have it with ours. There's also some collide with options, areas or bodies. We're only really worried about bodies here. Areas are different. They're like a collision shape, but instead of really providing collision information, they just provide like overlapping kind of information, like am I in the area or outside, but they won't prevent movement like a static body would. Okay, so that's all we really need to do to set up this raycast 2D. Let's go ahead and give it a name though, because this raycast 2D is going to be used for a very specific purpose in our game, and it's going to be our, I'll call it a one-way platform raycast. I even spelled that right on the first try. I'm getting better, guys. Okay, so this raycast is our one-way platform raycast. That's what we're going to use it for, just to tell us, are we on a one-way platform or not? Okay, now to demonstrate this, I'm actually going to extend the length of this just a little bit to like 10. And I'm going to come back into my debug and turn visible collision shapes back on, because this is also going to draw this raycast arrow while we're playing the game. And you'll see that it's going to change color. So right now it's red because we're on a one-way platform. And when we go off, it's blue. Okay, so meaning it's not detecting any collision with a one-way platform, but here it is. Okay, is that making sense? Pretty simple. Now coming back here, we can go ahead and set this target position back to 4 so it's nice and short. If that didn't work for you, by the way, then make sure that your layers and your layer masks are set up accordingly to what I've shown earlier in the video. So the question is how are we going to utilize this raycast to help us know if we can jump down? Well, let's go ahead and go back into our player script. So just like we've brought in this reference to our sprite and our collision shapes, let's go ahead and get a reference to our one-way platform raycast node. Okay. And so now we can read properties of this. And we're only really interested in what this is doing when we're in the crouch state right now. So I'm going to come into the crouch state. And then let's just look at this here. So we have our handle input. I'm going to go ahead and remove that comment. Don't really want it anymore. We're checking if they press the jump action. And then when they do, we just need to do a check. Okay, so were we on a one-way platform or not? And so we can say if player dot one-way platform raycast, right? If this is colliding in it, and because this is a raycast, it has a method we can call the check. So it's dot is colliding. Okay, so if that equals true, then we know we're on a one-way platform. So in this case, we don't want to jump. We want to do something else. Otherwise, we can jump, okay? So what do we want to do if we're on a one-way platform? And what we want to do is we want to fall. But that's not enough because we're on top of this platform. And so actually, let's try it. It might not be enough. I don't know. Let's just see what happens. I'm crouching and I press jump. Yeah, you can see it's still staying right there. So I'm going to come back here. In order for this to work, we just need to bump our player down a couple pixels so that he's no longer sitting on top of this, and then return the fall state. So what we'll do is we'll say player.position and .y, right? We just want to adjust his Y position. And then we'll say plus equals 4, something like that. So 4 pixels. So he's going to get nudged down 4 pixels and then enter the fall state. So if I save this and go back to my game, if I crouch and press jump, boo, I fall right through. And there we go. But that'll only happen when our little raycast is detecting. So when we're on the ground, we still jump like normal. Okay. Now this is a feature that some people may not love, because that means you may be fighting an enemy on a one-way platform and try and jump over a projectile, and instead of jumping up, you jump down. But it is what it is. You can refine how that feature works if you want to. You can bind it to a different key press. But so far, I think it's working pretty slick. So there we have it. We've added a pretty robust crouch feature. We've introduced you to some new features like the raycast 2D and working with collision shapes and their collision layers, as well as the ability to set up these one-way platforms. So a pretty meaty little episode. Thank you guys for following along. If you have any questions, go ahead and post them. Now the homework assignment. So the homework assignment is going to be a little bit different this time around. In our next video, we're going to be tackling the sprite sheet for this player, as well as animations. And so that's really chunky. It's going to be another chunky, beefy episode. I may even split it up, but right now I plan to do it as one. So what the homework assignment is maybe you have a sprite sheet. You could try and assign and use the sprite here. Learn about the sprite sheet. But really what I want you to do is to create your own sprite or explore the sprite that I have available on the itch.io page that you can download. So if you open that up, you'll see that there's a player that's got animations. He's got a lot of repeated frames because it's a basic placeholder sprite, I would say. And some of the animations are only a few frames long. But what you can do is, if you're familiar with creating a sprite, maybe go in there and manipulate it somehow. I will be making a brief video about how to open that sprite sheet in Sprite so you can get started playing with it. It'll be just like a little addendum to this chapter that'll come out before the next episode. And so what are we on? This is episode 6. Episode 7 will be the sprites and animation. And so there will be one in between, like a 6.5, okay, with some details on how to open that sprite sheet up. So I want you guys to work on the sprite sheet. You need to be prepared in the next video to be able to bring your character in, whether it's mine or one that you've worked on, and begin animating it. And it's really going to make this little game come to life. So thanks for sticking with me. I appreciate everybody's support. Subscribe to the channel if you're new, because that's how you're going to know what's coming out, obviously. And as always, we'll see you next time.